Hey everyone, and welcome back. Today I made a fridge that doesn't work, but I suppose you need more explanation than that. My regular viewers will remember this. This is my cooling apparatus that I had built to cool LEDs. Basically, it's a water cooling rig to cool whatever I wanted to cool. Well, one of the things I wanted to do with that is build a little chamber and have a thermoelectric cooler in there, or thermoelectric generator. So one of these guys. So that's exactly what's in one of those. What these things do is that when you put a current through them, one side gets hot and the other side gets cold. It basically pumps energy from one side to the other. And if you can dissipate the energy out of the hot side, the cold side will get colder and colder. And yeah, these things are really cool. I wanted to play with them. So I went to the dollar store and I got some foam board. Now this is the stuff that maybe school science fairs and stuff will be presented on. It's just basically foam sandwiched between two pieces of paper. You can even make model aircraft with it. It's pretty cool stuff. And I cut and hot glued together a box in order to have an insulated volume of air that I can chill down. And yeah, I put a little thermometer here so we can see the temperature inside the box, but it didn't quite work. These thermoelectric coolers, if you can't get the heat out fast enough from the backside, basically the heat will permeate through the layers and the hot side will heat up the cold side. And I thought that's what was happening here until I started recording and I turned off my setup. And then I found condensation on this cooler, which you should be seeing now, which means that it was working, but there is a problem. So I think I know the problem, which is good. But let me show you this thing first. So yeah, this is a piece of plastic I had in stock, just whatever. I glued it to the bottom. I made a box. It's about 12 centimeters by 20 centimeters. I did this so I would have enough space to put cool stuff in here, and also so we can see the heatsink on this side. Now, for the hot side, it's being cooled by the cooling plate for my water cooling setup. These are all super cheap Chinese components. If you go look at the original video for this thing, which is linked below, I think all the links are there. But I built this in a way that it could be modular. So I have these rubber bands. Like this, and this pulls out. And so the goal of having a heat sink on this side, this is actually a cold sink. It's not really a heat sink. So basically it's supposed to take the cold off the tech. Oh, look at that. Can you see the condensation on that? That's a lot of condensation. But anyways, it's supposed to take the cold off the tech and basically push all the warm air that's in the box through these fins to cool down that air and have a full circulation going on in there. But the problem is that this heatsink is actually, it doesn't have a big enough contact spot. You see these techs, the whole surface gets cold. And I think this thing here has a heatsink surface, has a contact surface, which is like the middle half, let's just say. So there'd be a quarter of no touch, a quarter of no touch, and then half the thing has contact. So I think what's happening is we're able to dissipate away the heat properly into these lines here, but I'm not able to have the tech cool down this heatsink enough for the air passing over it to get cool. So that being said, I have this other cooler. This is a cooler from AMD. This would be a Ryzen 5 2600 or something like that. It's a Wraith I think the cooler is called a Rate Stealth. I don't know. A friend of mine gave me this for free, and this has a contact patch which is the size of a tech, almost exactly. So my only downside now is I don't have a retention mechanism. Right now, this is taped on with thermal adhesive, like thermal tape, and so is the other side. And how I did it is I actually thermal taped the tech down onto this cooler, and then thermal taped the water cooler onto that, and then I integrated it into a back plate. I could just rip this off and make a new back plate for this one, which is probably what I'll eventually do, but for now I can show you the behavior of a tech. This is my box here. As you can see, just hot glue joints in here, and the piece of plastic was just cut to fit with hot glue everywhere, and the thermometer is very purposefully as far as possible away from the cool source, because I want to know when the whole box achieves that temperature, and it just happens to have a hygrometer on there too. So yeah, let me put this back together and I'll show you how I've been controlling this thing. I hope you can see everything, but this is pretty much how I had it running. I just had it running at a set current limit. There's a voltage limit of 14 volts, but current limit is what adjusts it. You limit the current, and the power supply lowers the voltage to match. And so yeah, I just had it running like this, and there was no drop in temperature, even though I can feel this plastic's a little cool. So what I did is I used this, I believe this is from IC Station, the thermocouple here, and this wand is actually from some mailbag, and I would just touched the thermocouple onto the heatsink, and you'll see the heatsink. So the internal temperature is reading 21, but the heatsink is, well, it's below 20. So I think what the issue is twofold. There's not enough metal in this heatsink in order to, when the air rushes over it, to get cooled down enough, and there's not enough contact patch on the tech. See, the heatsink is down at like 19.3 now. It's cold enough. But anyways, this is what I was doing. I was adjusting the current. So let's go 2 amps, enter, and then I would see how the heatsink reacted. Because even though the heatsink gets colder, sometimes, this is what I'm checking, it doesn't necessarily mean that the air got colder. So yeah, I think there's a double thermal transfer issue. Too much problems transferring the heatsink to the ambient, and from the Peltier to the heatsink. And I mean, everything else is working. The hot side, I would also probe the hot water here, and it wasn't actually, it didn't even warm up that much. This thing is doing just fine. But you can see here, I went from 1.25 amps to 2 amps, and we're not really going down all that much. And that's why I'm thinking it's probably a problem with the transfer. I'm trying to jam the probe down onto the Peltier, and you see the actual, the cold side of the Peltier is down, 15 or so degrees. I'll pump this up and see if we can do more. Let's see, let's go 3 amps. So we're at 26 watts now of potential cooling power. And there you can see that my probe here, you can tell we're cooling quite a bit. But the air inside here isn't getting much colder, and I think that's why. Small contact patch from the Peltier to the heatsink, and not enough metal from to transfer from the air to the heatsink. See, 13 degrees, that's not too bad. We can go full bore and see what happens here. Let's go 4.25, so 4.25 amps. So that's pretty much full bore for this module, about 60 60 or so watts. And the thermocouple isn't perfectly on the Peltier unit there. You see? Now we're having issues transferring the heat into the block here. Into this radiator system, because now the temperature is going up. So basically what's happening is that the hot side is not getting cooled enough, and it's transferring over to the cold side. So we can get the Peltier again. Yeah, so this is how I was adjusting it. I would just, put a current value and see what happens. So if I drop this down to 2 amps now, they should start getting cold, because now the heat should be getting taken away by this cooling system. Although not that much, surprisingly. Now here we go. We're recovering. So 15.2, 15.0, but yet the temperature in here, I don't know if you can see that, temperature is still 21, because even though the Peltier is down, in the tens of degrees, if I put the probe onto the heatsink, it goes up. Like, the heatsink is not doing a good job transferring removing the heat from the air inside here. Yeah, terrible. So, not a good heatsink, not a good contact patch. I'm going to have to revisit this in the future. I was just about to film an outro letting you know that I designed these plates here so I can just make a new plate and try a new cooler setup and whatever. And I accidentally hit this thing with my thumb. And I broke it, and a blade went flying across the room. So this iteration is definitely going to die at this point here. But I still need to take thumbnails and stuff. So yeah, thought you would like that. But I purposely bought this block here so that it would fit 2 of these tech units. Trying to flip this over. Oh, pulling a little bit on the wires here. Well, I'm just going to turn it off. Doesn't matter. Yeah, I bought it so that it would fit 2 of these tech units. Like so. So if I need to double up on them, I will. I just need to get a piece of aluminum on this side to link the 2 cold sides together, so I can use a single heatsink to move the air around. But yeah, that has been my little bit of tech experimentation, and hopefully I can get a working cooler chamber for the future. But for now, I want you to go down in the comment section and let me know, if I get this cooling chamber working, what sort of experiments would you like me to perform with it? Because this thing is supposed to be multi-purpose. Cooling, heating, basically whatever we want to do with it. The techs also work in reverse, and we can also just put a heating element in. So yeah, let me know what you want to see in the future. This is my little bit of tech experiment. Thanks for watching.